Let's continue. Now the next session will be about now calculation. Let's start to calculate. We'll start with the easier questions so that at least you get the confidence in dealing with calculations on involved in electric circuits. So very important one is about the resistance, remember, in circuits, and the current. If you can trace the two, you will be finding electric circuits calculations as very important and easy to deal with. Resistance and the current, those are the two very important ones. Fine, let's talk about this one. They say calculate all unknown values in the circuits here. We are given the first circuit, it's like this, and now when we look at these circuits, we have got in all these cases the internal resistance is 0, small r is 0. The battery has got only EMF, there's no internal resistance. Fine, let's check. We are given the EMF of 20, and there's a R1 which has got V1. We've got two unknowns there, but we know that the current flowing through R1 is 10, and the current flowing through 0.4 is 10. And obviously now we know current and the resistance, we can calculate V2. The current again on A1 will also remain 10, I hope, yes. And then when we know the current here and the voltage, we can find R2. Can we start? Yes. Let's start with V2, the easiest one. So obviously, according to Ohm's law, we can know that now R equals to V over I. Or if you master your stuff, you can just say V2 equals to IR. It's okay, that one also will be the case. If you deal with this one, you will now say resistance is 0.4, and the voltage is the one I don't know, the current is 10. So if you multiply 10 by 0.4, therefore the voltage will be 4 volts. So I mean that the voltage V2 is 4 volts. Now I can move to knowing now that the A1, we say according to this one now, the given information here, this will give us the same answer. So V1, where A1 will be the same as 10 amperes, because we know that the current flowing through here is the same as the current flowing through past that ammeter. Now if A1 is 10, therefore the current flowing through R2 is 10 as well. I know the current and the voltage, I can calculate the resistance of R2. Therefore R2 will be the same as V over I, which will give me 4 over 10, which will be 0.4 ohm. So R2 and this one, they are the same. Fine, let's go to R1 now. According to this one, how do we find R1? We must know V1. So what will be V1 now? According to this one, therefore we know that the EMF will be the same as the EMF in this circuit, in this one, this circuit, which is 20. Therefore EMF would be the sum of V1 plus V2 plus 4 volts. So because we say series connections divide the voltage, the total voltage here will be the sum of V1, V2 and this one. We already know V2 is 4, this one is 4, this will be. Let's continue. We were on in this case to say the total voltage in the circuit, which is 20 volts, equals to V1, V2 and 4. Therefore the EMF we know is 20, V1 is the one we are calculating, V2 is 4 and this is 4. Therefore V1 obvious will be the same as 12 volts. So if V1 is 12 volts, we know here now the current flowing through R1 is 10, then now we can find R1. Therefore it will mean that now R1 will be the same as V1 over current. Therefore V1 is 12 and the current is 10, therefore it means that this will be 1.2 ohm. That is the R1. So we are done with the first circuit. Let's go to the next circuit, whereby now also the internal resistance is 0. Now if you look at this one, if you trace resistance and current, because those are two main ones, well, the total voltage of the circuit means that 5V is equals to V1, V2 and 1. So we don't know 2, fine. Let's see, where do we know? According to this one, they are telling us that the A1 here is not known, and this also here. Oh, here is the hint now. So we don't know 2 here, we don't know the current, we don't know the resistance, we can't calculate. But here we know the current and resistance, therefore we can know V2. That's the first one. Therefore V2 in that circuit, V2 will be IR. IR in this case, which will be the same as your 1 multiplied by 1, which is 1 volt. Can you see now? If V2 is 1 multiplied by 1, which is 1 volt, also across the 4 will be the same as 1 volt, because remember, voltage in a parallel combination is the same. So the voltage across 4 ohm is 1. You can calculate the current flow in there. Yes. Therefore, R equals to V over I. Resistance is 4, and the voltage is 1 divided by I. Therefore, I will be the same as 1 over 4, which is 0.25 amperes. Now, yes, if this one is 0.25, we know that now the total current will be the sum of these two. Therefore, the ammeter reading will be 1 plus this, which will be 1.25 amperes. Fine. If this is 1.25, we know that without calculating, therefore this will also be 1.25 amperes. Fine. No problem. Where do we know now? We know that this one is 1 volt. Yes. If this one is 1, this is 1. What is this one? According to this one, therefore V1 will be 3 volts. If V1 is 3 volts and the current here is 1.25, we can calculate R. You can just do it here to say, therefore R equals to V over I. Therefore resistance is the one we are calculating. Voltage is 3. The current is 1.25. That's how it is. Therefore, what is 1.25 into that, into the 3? Then it will be now, the answer will be 2.4 ohm. Fine. So that is R1. R1 will be 2.4 ohm. What else we don't know? We don't know R2, but we know this is 1 volt and this is 1.2. So obviously we can calculate R2 in this case. R2 will be the same as V over I, which is the same as 1 over 1.25 in this case. I hope you can see that one. So this, what will be the case now if you look at this one? So then the answer here will give us 0.8 ohm. 0.8 ohm. That is how you calculate if given this information and you trace current and the resistance. Very important, and with the voltage as well. Fine. Let's go to the other level now, where now we are dealing with the internal resistance. So the internal resistance here is the question. They are telling us to say, look at this circuit. In the circuit below, the battery has an EMF of 24 volts. Yes, the EMF here is 24 volts. An unknown internal resistance, R is not known, small r. V1 is connected across the battery, yes, and reads 20 volt. The resistance of the connectors and the ammeter may be ignored. So when switch S is closed, the voltmeter V2 is 4 volts. Yes, we see it here. And then V1 is 20 volts. Fine. So fine, let's go and see. Calculate the reading on A2. A2 is the current flowing through 4 ohm. Therefore, I know voltage and resistance, I can calculate the current. Therefore, resistance equals to V over I. Therefore, resistance is 4. The voltage is 4 divided by I. Therefore, I here on the A2 will be the same as now 1 ampere. Fine. If this one is 1 ampere here, we can use logic now, proportion. The current through here is the 8 ohm. The current through 8 ohm is 1 ampere. When we double, this is 16. When we double the resistance, what's happened to the current? The current is halved. Therefore, it means that now, if I can connect the ammeter here, that ammeter will read 0.5 amperes. Fine. Then, because they even say to us here, the second question, calculate the reading on the ammeter A1. A1 is the total current in the circuit. So it will be the sum of 1 ampere plus 0.5. Therefore, the reading on A1 will be 1.5 amperes. Fine. 1.5 amperes because it's a total. Remember, the parallel combination divides the current. Now, calculate the resistance of R. This is the resistance of R. Now, no problem. If the voltage across 4 ohm is 4, then without even being told, we know that if I can connect the voltmeter here, what will be the reading now? It will also read what? 4 volts, because the current is the same. So V equals to IR, 1 multiplied by 4 will be 4 volts. Now, the total voltage of the parallel is 8. If the total voltage of the parallel is 8, therefore the voltage across R, if I can connect the voltmeter here across R, what will be the reading? It will be now 20 minus 8, which is 12 volts. 20 minus 8, which is equals to 12 volts. That's most important. Then say trace resistance, fine, and current in this case, and the voltage. No problem. Now, if this one is 12 volts, but the current flowing through it is 1.5, now we can calculate R. Therefore, R, yes, we calculated, in this case, we were calculating this one resistance across R. Once we calculated the voltage of R, which is the difference between the total voltage that is applying the whole circuit, parallel consumes only 8 volts, and then the remaining energy will be for the R. So R equals to V over I, which will be the same as 12 divided by 1.5. Then this will be 8 ohm. That will be 8 ohm. Fine. No problem. Now the next question, they say calculate the internal resistance of the battery. Now we know in this case the current flowing through in the circuit. We can calculate the internal resistance of the battery. So the internal resistance of the battery will be from the formula. Remember, we've got two options. You can utilize I equals into this one, R external plus R internal. We know the EMF. We know the current in the circuit. This one we don't know, but we can calculate it. It's fine. It is another step. So the easiest formula will be the one of E equals to V plus IR. Therefore, in this case, we know this one, this one is 20, this one is 1.5. We can find this. So the easiest will be that one, 24 equals to 20 plus the current is 1.5 multiplied by R. Therefore, this one, the small r here, will be in a way a 2,67 ohm. That will be the internal resistance of the battery. Now they continue again to say calculate the energy converted in resistor R in 10 minutes. So now energy dissipation now. Fine. We know how to find the energy dissipation. As long as we know the R, the energy will be, now we know the current flowing there. You can just use I squared R delta T, which will be now 1,5 squared multiplied by 8 multiplied by 10 minutes will be 10 multiplied by 60. Then you'll find the energy in joules in that case. I don't calculator will be next to me. Then the last one will be calculate the rate at which heat is produced. So the rate of producing heat is power. That's indirectly. You're calculating power now to say, therefore, how do we calculate the power? Power equals to, in the 16 ohm, we can just say power equals to VI. You've got option power equals to I squared R. You can say again power equals to V squared over R. So in this case, all these are applicable in that case. The easiest one, the voltage across 16, we agree that is 8. And then the current flowing through 16 is 0,5. Therefore, the power there will be 4 watts. I hope it's clear so far about calculating, doing questions in which involve the circuit where the internal resistance is not negligible and the circuit where internal resistance is negligible. I hope we did both, and this one built a good foundation and very solid one for you to focus, maybe even solve the other related problems. We'll do more in the next coming session, so that at least we take one paper recent and then we do, which will be might similar to this one. So we do and answer that one. So until we meet again, thanks a lot. Bye.